So this is for a couple of you guys who asked about uh, product and sum, factoring type of problems. There's a few of you who messaged me saying you wanted some help, and I'm sorry if I'm a little late to get back to some of you guys, but it's not always easy to find time to do like extra work, but I'll do what I can when I have a minute. So I'll try that now for you. So I'll just make some problems up. I have absolutely no planning in this, so we'll just kind of go with the flow, and I'll try to explain how this works as best I can. Okay, so let's just make a problem up and let's start with that. So let's say we have x squared plus 13x plus 42. And we want to factor this. Let's say, this equals 0, right? Our goal is to factor this and solve, find out what x can be. So there are three terms. Hold on a second. So there are three terms, and when we factor three terms, we're going to use our product and sum method. So how the product and sum method works is, I think in my class, I use this x thingy here just as an organizational thing. But it doesn't really matter how you organize your thinking. What matters is the numbers you come up with. So if you're using the quote-unquote x thingy that we have here, on top you're going to put the a times c value, and on bottom you'll put the b value. So this quadratic is ax squared plus bx plus c. So in this case, a is not x squared, it's the coefficient in front of x squared, which since it's just an x squared, that means the coefficient is 1. So a in this case is 1. B is the coefficient in front of x, so b in this case is just 13. And c is 42. So if I were to do a times c, 1 times 42, that number would be 42. And I'm going to put that number up there. This is not part of the problem at all. This is just part of kind of organizing my thinking again, okay? So I need to know what a times c is. That number is 42. I need to know what the b number is as well. The b number, which is pretty straightforward, is just 13. Now here's the part where we actually have to do some thinking, okay? That's just setting it up. That's just setting up my puzzle, my process. Because now what I need to do is find out what two terms are going to multiply to make 42. That's why it's called the product. And add to make 13. That's why they call it the sum. They have to be the same two numbers. So this is where it's tricky because you have to kind of be good at your multiplication facts. If you know your multiplication facts pretty well, then this shouldn't be too hard. But I want two numbers that multiply to 42 and add to 13. And if you haven't yet come up with it, those numbers are going to be 7 and 6. 7 times 6 is 42, and 7 plus 6 is 13. So now those two numbers are important. That's the whole reason I made this x thing. You don't have to organize it as an x thing, by the way. If you want to draw it out differently, you can. You can just say something times something will equal your a times c, and something plus something will equal your b value. That's essentially what the x thing does. But again, it's just a visual depending on how you want to organize your thoughts. So yeah, a times c was 42, b was 13, and this is just another way of kind of illustrating our point. But we get the number 7 and 6, which is what we want. Now what's going to happen is I'm going to use these as x terms. These two numbers, I'm going to make them x terms, and I'm going to use them to replace this original x term. So my quadratic originally, right, let me just write it back down, was x squared plus 13x plus 42. But what I'm going to do with the numbers that I just found, the 7 and the 6, is I'm going to replace this middle term, that 13x, I'm going to replace it with these two terms that I just got. So a positive 7 and a positive 6. So plus 7x and plus 6x. And I'm going to throw them in the middle. So I have x squared plus 7x plus 6x plus 42. So I have 4 terms now instead of 3. And it's still equivalent to the same thing because if you add 7x and 6x, you get 13x. So I haven't really changed any value of the problem. But what I'm going to do from here on out is, since I have 4 terms, I'm going to factor my 4 terms by grouping. So to factor by grouping, it's pretty straightforward. You always group the first 2 terms together and the last 2 terms together. So in this case, I'm going to group x squared with 7x, first 2 terms, and I'm going to group the last 2 terms, which is 6x and 42. Now, what I'm going to do with those groups is I'm going to GCF each of them. So a GCF means what you're looking for in each of these groups is what do the 2 terms have in common. So in this case, I'm going to look at this first set of parentheses. So I'm looking at x squared and 7x, and I'm thinking, what do these 2 terms have in common that I can divide them by, or how many variables do they also have in common? So between 1x squared and 7x, there's no number I can divide them by other than 1. So I'm not going to worry about that. But both terms do have at least 1x that I can take from each of them. So I'll factor out an x out of each of these, and that x doesn't disappear. That x just gets moved outside of the parentheses, outside of that group. So the x will be in front now. So you still technically have 0 here, although we're going to kind of ignore it for the sake of the rest of my factoring. But it's technically there. Now, when you divide out the x, what do you have left of your first term? Right, x squared. If you take an x out of that term, then it's only going to be x remaining there. Let's use a different color. I like being colorful. You know, it makes me happy here. So we get x there. Now, the 7x. When you divide an x out of that term, those x's are going to cancel, so you just get left with 7. Now let's look at the second group. The second group. Same idea, GCF. What do these 2 terms have in common that they can be divided by, or how many variables do they each have? Now, 6x and 42. Both 6 and 42 can be divided by 6. And that's all they have in common because there's no x terms in both. There's an x in the 6x, but there's no x with the 42. So I can't divide out any x's. All I can do is divide both of these by 6. So just like the x in the first part, the 6 will come in front here of the parentheses, and then what I have remaining is, well, 6 divided by 6 will cancel out, so you'll have an x remaining with that first term, and 42 divided by 6 is 7, so you have 7 remaining in that second part. And I really should have used my colors, man. Anyway, go ahead and make that x plus 7. All right, so to finish our factoring, we've got, you should have the same binomial from each group. So I got an x plus 7 from the first factoring, and I got an x plus 7 in the second bit of factoring as well. And that should always happen. They should always be the same. And so to finish our factoring, we take that common group, and that common group becomes one of our factors. So x plus 7 is one of our factors. The other factor is what's outside of that group, which in this case is x and plus 6. So x plus 6 makes up the other binomial factor. So there you go. There you factored it. You have the factors x plus 7 and x plus 6. Remember, it's all equal to 0. So now to finish the problem, all you got to do is set each of these equal to 0 and solve them. So you have 2 equations essentially. You have x plus 7 equal to 0, which a lot of times you can probably do this in your head, but I'll just go ahead and work it out because, you know, sometimes it's a little more complicated than this one. So you have x equal to negative 7, and then you also have the other binomial, x plus 6 equal to 0. So set that equal to 0 and solve it as well. So subtract 6, and you have x equal to negative 6. So there's your 2 answers, your 2 solutions, x equals negative 7 and x equals negative 6. If that's enough for you, that's great. You know, turn the video off and go about your day. I'm going to do another problem. But remember this one because I'll reference it later. But I think I have to, can I save it? Nope. I don't know if I'm saving it or not. But anyway, I might not be able to come back to this because I'll have to delete it. So, but I'll reference it later. Okay, so you can just rewind, I guess, the video if you need to. But let me do maybe one more. Okay, so let me make one up. Let's do 3. Now let's just make it easier. Okay, let's just do 2x squared plus, I gotta think first. Again, I didn't plan any of these out. The c value, let's make the c value 12. So negative 10x. Let's say it's 2x squared plus or minus 10x plus 12. Actually, just to make it a little more interesting, let's say it's plus 6 equals to negative 6. Let's say I have this as my quadratic. Now, the issue is you can't really do anything until the quadratic is set equal to 0. You have to make sure it's ax squared plus bx plus c equal to 0. Otherwise, you don't really know what a, b, and c are until you have it equal to 0. So I changed it up a little bit. So let's say I have this problem to start with. I need, first and foremost, to make sure I have ax squared plus bx plus c equal to 0. So that means taking this negative 6 over here and moving it onto that side so that we have it equal to 0. So that would mean adding 6 to both sides. And then you would have the equation. You'd have 2x squared minus 10x plus 12 equal to 0. So just keep that in mind. Sometimes it's not set up properly, and sometimes you have to do just a little bit of work to set it up right. But now it's set up right. So now what I'm going to do is I'm going to use that product and sum again. I got 3 terms here in my quadratic that I need to factor. I'm going to use my x thingy one more time to sort of, draw out my thinking. So remember, I need to know what a times c is, and I need to know what my b value is. So a in this case is 2, and b is negative 10, and c is 12. So if I do a times c, I'm doing 2 times 12, and 2 times 12 is 24. So I need to know that number. I also need to know what b is. B is negative 10. So now here's the catch. I need to know what 2 numbers are going to multiply to my product up here of 24 and add to my sum of negative 10. So what 2 numbers multiply to 24 and add to negative 10? I'll let you think about it. I'm going to write this down again as well. So again, you don't have to use the x thing. You just have to think of it like this. Something times something equals a times c, and something plus something equals b. So in this case, that's something plus something equals 24, and something minus, or something times something is 24, and something plus something is negative 10. So same idea, okay? Have you thought of those numbers yet? If you haven't, keep in mind that it multiplies to a positive and adds to a negative. So the only way that can happen is if both numbers are negative. A negative times a negative will make a positive 24, but negative minus another number will make a negative number as well. So that's a hint for you. Now, if that's not enough still, the answer there is negative 6 and negative 4. Negative 6 times negative 4 is positive 24. Negative 6 minus 4 is negative 10. So again, just like the last time, these 2 numbers are crucial. We're going to use them as x terms to replace the original x term. So if I write out my quadratic instead with those 2 terms instead of negative 10x, I'll have 2x squared. And I'll still have plus 12 down here as well. All right, but instead of writing minus 10x in the middle, I'm going to write minus 6x and minus 4x. So those 2 numbers are always very important because now I have the 4-term quadratic. And when I get the 4-term quadratic, I factor by grouping. So I group the first 2 terms, and I group the last 2 terms. Now I'm going to do slightly different here because I have a negative 4, and I need to make sure that the negative is inside those parentheses because that minus sign goes with that 4 because it's a negative 4. If there was a plus sign, it wouldn't matter. But a negative sign does matter, so make sure you include that inside the parentheses when you draw them. All right, now let's factor our groups. So the first group, 2x squared and 6x, both 2 and 6 are divisible by 2, and both terms have at least one x as well. So I'm going to factor 2x and bring it in front. Now, when I divide that 2x out of each term, 2 divided by 2 will cancel, and I'll have x squared take away an x means I'll have 1 x remaining here. Negative 6 divided by 2 will be negative 3, and then again, those x's will cancel, so I don't have any more x's there. And then moving on to the second group, -4 and 12. You can divide both of them by 4. However, what we're gonna do is divide them by -4, and I'll explain that after I'm done factoring. But well, I could explain it now. When I divide by a -4, what's gonna happen here is the negatives are gonna cancel as well as the 4, leaving me with a normal plain x. And then 12 divided by -4 leaves me with -3. So I divided by a -4 because I needed to make sure that this parentheses and these parentheses, those two groups, matched. If I didn't divide by a negative, if I just divided by a regular 4 instead, then my second group would have been a -x and a +3, which is not what I want. I need it to be the same thing. I need it to be x minus 3 since that's what I got in the first group. So dividing by that negative made sure I had that positive x and then -3 to match this first group. Now, same thing as before, these two groups match, so that's going to be one of the factors we're going to write down, x minus 3. The other factor is what's remaining outside of those parentheses, which is 2x minus 4. So there you go, there are your two factors. Remember, this is set equal to 0. So now all you got to do is set each of those binomials equal to 0 and solve them. So we're going to take x minus 3, set it equal to 0, and when you solve it, you get x equal to positive 3. And also, I'm just going to use the same space because I'm going to run out of room otherwise. Take the other one, the 2x minus 4, equal to 0, and solve it. So adding 4 to both sides, you get 2x equal to 4. And then when you divide by 2, you have x equal to 2. Okay, so x equals 3 and x equals 2 are my answers. One thing I do want to point out, if I don't know what type of questions you're asked on your test, but if you just need the solutions, then everything I did here is fine. But sometimes if you need to factor it completely, I've made a little bit of a blunder in the fact that this 2x plus 4 here, or 2x minus 4, is not completely factored. So let me just clear up some space and I'll come back to that. So x minus 3 and 2x minus 4 are my factors, correct? Now, x minus 3 is fine. It's completely factored. I can't do anything about it. But this group actually has a GCF in it still. Both of these two terms are divisible by 2. And what you should do if you want to factor it completely is divide that 2 out and stick it all the way in front of the parentheses. So really, I mean, it sort of goes here, really, but it doesn't matter because you're multiplying the 2 with this and that anyway. So it's just going to be kind of more pleasing to put it in front. So you'd factor the 2 out. X minus 3 doesn't change, but when you divide the 2 out, this becomes x minus 2 here. That doesn't change the problem at all, even if you take the 2 out, because when you set this equal to 0, you know that's still going to be the same x equal to 3. And when you set this equal to 0, you still have the same x equals a positive 2. So the answers don't change. But I just wanted to point out that what I wrote down originally, this isn't necessarily completely factored because there was a GCF in that group. So this is the technically correct completely factored version. However, it's not going to make a difference when you want to solve for x and get your answer. So again, I don't know if the question's asking for you to factor it completely or if it's just asking for the answers, because if it's just asking for the answers, then that didn't really matter. All right, but that's your product and sum. The key to this method is really two things. Finding the correct values when you do your product and sum box thing. Finding these two numbers correctly. That's very important. And then making sure that you plug them in and factor by grouping. That's really all it is. It just takes some practice to get used to. But I hope it helped a little bit, you know. It's not easy to find the time to do these things, but did the best I could. If you need any more help, just let me know. Okay? Bye.